Hello everyone. So today is our uh, third day of course of of Road to Mang series, and today's question is good. And I did the brute force approach, and of course it will give daily, and I learned the optimal method. So let me first explain the brute force method. So the question says that we have got two positive integer n and k. Sn is a binary string. N represents the ith uh, binary string. So k is the index of Sn, and we have to return that index. Is it 0 or 1? Since Sn is a binary string, so S1 is 0 given. Si is S of I minus 1 plus 1 plus reverse of inverter. So this means if we want to find h2, we have to do s of 1, that is 0, plus 1 plus invert of 0, that is 1, reverse of 1, 1. So 0 1 1. For third example, s2 is 0 1 1, 0 1 1, then 1, then invert of 0 1 1, that is 1 0 0, then reverse 0 0 1. So this is 0 0 1. So same for 4, s4. So so the pattern, initially it seemed like 1 3 7. So it's simply 2 to the power 1 minus 1, 2 to the power 2 minus 1, 2 to the power 3 minus 1. The length of the string is like this. So let me explain my brute force approach first. So I am creating two functions. One is invert, that which will invert this s of I minus 1, and this is the recursion part. This is the base condition. If I equals 1, then 0, it will return 0, else it will return previous one, then invert of previous one. Then this is the simple approach. Now the optimal approach here is, let me show you. Okay, so the optimal approach here is the pattern. Here is the pattern. So if we see this is the pattern. So here we always get the middle element as 1. If k is, imagine k is uh the middle element of length, mid of that length, then we'll simply return 1. Mid is the length of that binary string. So if the length is 3, then the middle is 1. If length is 7, the middle is 4, like that. So we have three conditions here: if k is middle or not, or k if k is less than mid or not, if k is greater than mid or not. So let's see for uh, k less than mid. If it is less than mid, then we'll simply return the previous value, and it will simple recursion will follow. But where is the issue of TLE here? Where TLE, where does TLE comes here? Here TLE comes when we unnecessarily create whole string to find like this one. So the pattern here is these both are related. These both are related, like s of I minus 1 and invert of s of I minus 1, and reverse it. Both are related. So we can find these indexes from these as well. So how? If s of I is if s of 3 is this, if k is 1, we'll simply return 0. If k is middle, then we'll 1. If k is less than, we'll simply do the recursion and find it. But if it is greater than, so how we'll find this index? How will return fifth index? So it is like that. So to get fifth index, this is same as what is this? How it is formed? It is formed 0 1 1. We have to invert it 1 0 0 and then reverse it. So simply we will first uh, get how we'll get this and this, since these both are related. Since this is this and this are related, how these are related? Because it got reversed, right? So we'll get this index by length of this, length of this, minus this index plus plus 1, cause we are finding from the right. We are finding from the right. How we'll find fifth index from right? We'll find fifth index from right by index of 2. Sorry, index of 3. That is 1, 2, and 3. So third index, that is the third index. So fifth index from left is same as third index from right. So if we find third index from here, so these both are related. Third and fifth are related. Or second and sixth are related. First and last is related. Like this. So this, how this became this. If we invert this, simply invert this, we'll get the value. Okay. Invert this. You are seeing invert, all are inverted. This one, this one, this one, this one, all are inverted. So the code here goes like this. If k is less than mid, then we'll simply do the recursion. Else the TLE part, to handle it, will do recursion here only. We'll do recursion, try to forcefully recurse it within itself. Okay, so the code, let me write the code. So if, simply if initially n equals 1, will return 0. That is the base case here. The length of string is 2 to the power n minus 1. Of course, 2 to the power n minus 1, right? S of 4, 2 to the power 4 minus 1, that is 17, sorry, 15. Now what we need? Length, we found the length and the mid value. Mid equals length plus 1 by 2. Now we'll do the recursion. If k equals mid, then we'll simply return 1, because it is always, since 1 is always in the mid, we'll always simply return 1. It is always true. And if k less than mid, we'll simply return self, object oriented programming, guys. So find kth bit, we will go to the previous value and simply return k. Else return, we will not return here, we will store first, cause we have to invert it at last, right? So the code here goes like this: self dot find kth bit n minus 1 comma. How we got fifth index? We got fifth index by length of that string minus that index plus 1, cause we are getting third index from right. So length minus k plus 1. Okay, and if answer equals 1, we'll return 0. I will show you the dry run here. Else we'll return 1. Okay, that's it. That's the code. So it should work. Okay, it will get submitted, of course. Now, how the k? Let me show you the dry run part of, if the case is mid greater k greater than mid. So let's take 3, this part, 3 and 5. If n is 3 and k is s is 3 and k is 5 and 5. So initially f of 3, is n equals 1? No. Length of the string to the power 3 minus 1 7, mid is 4, that is length plus 1 by 2, 8 by 2 4. Answer is f of 2 comma 3, because f is now n becomes n minus 1, k becomes, since mid is um, greater than, mid is less than k, sorry, k is greater than mid, that is 5 greater than 4. So we'll do length minus k plus 1, that is 5, length is 7 minus 5 plus 1, that is 3. So now after that the code here, this part is still there. Now it will go recursive call again, 2 comma 3, same follows. But here again, k 3 is greater than mid, that is 2, so it will return, it will again call. Now is n equals 1? Yes, it will return 0. So now answer value is 0. Now we'll go to line number 27. We check is answer 0, then we'll invert that. So now answer is, if answer is 0, then we'll return 1. Is answer 0? Yes, we return 1. We get this value, we'll get this value, this whole function value as 1, will return to 1. Is 1, answer value is 1 now. Is answer 1? Yes, we'll return 0 now. Okay, we will return 0 now. So this part value is 0 now. If you do the same for f of 3 comma 6, then also 0 will come. Do the dry run yourself. I think I understood, made it clear, but better communication I think we need. Of course this will get submitted. And guys, from tomorrow onwards, we will solve NSTQTD as well. Maybe two separate videos will come. Let's see. Of course, 0 millisecond. Wow, impossible. Let's see. That's it.